Right, we're going to look at division. Down the red corner here we've got the rule. Flip the second, then times. Now that's about as simple as you can write it, but let's see how this works. On this style, this is the sign for division using this. If that's annoying people, I can just put a standard division sign. So when we start, a half divided by an eighth. Now, if we think about it, a half divided by an eighth, the question really is, how many eighths can I fit into a half? If I was to draw a pizza again and cut it thus, I've now cut my pizza into eighths rather roughly, and if I was to shade in blue half the pizza, how many eighths do I have? The answer is I have 4. So the correct answer is 4. So my system must work for that. So flip the second. What that requires is a bit of a rewriting. So I don't do anything to the first, but I flip the second, and then I times. So if I flip 1 over 8, it becomes 8 over 1. And I'm not sure why I put that 8 there. I mean a 1. And so, if I follow my normal multiplication, 8 times 1 is 8, 2 times 1 on the bottom line is 2, which simplifies down to 4. Now, 4 was the answer we want because there is 4 lots of 1/8 fit into a half, as my lovely clear pizza illustration proves. If I've got a number like that, a situation with a number divided by a fraction, the other way to write this is 6 divided by 1 over 20. Now the same rule applies, and we can say, oh well, 6, that will be times, and then it will be 20 over 1. But before we blast through the system, and then that's a 1 you can ignore comfortably, so the answer is 120. But if we go back to the logic, the question here on this line, a way of saying this in words is, how many lots of 1/20th, how many 1/20ths can fit into 6? Well, the answer is for every whole number you've got there, you'll get 20 20ths. There'll be 20 20ths in 1. If you've got 2, it'll be 40. If you've got 3, 60, and so on. So we know the answer should be 120 because there's 6 lots of 20. So we could see the answer coming. We don't need to use the system if we can see it clearly coming, but the system works. If I apply it to an algebraic sort of business, everything's still firmly in place. There's no real changes. I could rewrite it. So 3x over 2x divided by 8 over x. And I've just realised it's not a good example. So I'm going to go 3x over 2x. Now they should be cancelled. The more astute among you will be thinking, and I'm sorry about that, x over 8. Now, it's definitely time for some cancelling now. As I would if I was multiplying, I'd look to cancel. Now, the x's can go. 1x is left standing on the top line. So I'm left with 3x on the top. I don't think I can get away from that. And I'm left with 2 8s, a 16 on the bottom, and that can't be simplified. And so I stop there.